Hello students, in this lecture we'll study two important theorems. One of them is divergence theorem and other is curl theorem. Now I will state two very important theorems which are very much used in electromagnetic theory. One of them is the divergence theorem. Second one is a curl theorem. Now let us consider the first theorem, that is a divergence theorem, and it was given, that means it was stated and proved by mathematician and physicist known as Gauss, and it is called as a divergence theorem due to Gauss or simply divergence theorem. Suppose there is a closed surface. See, closed surface has volume inside it. So there are two physical quantities there. It has a surface area and it has the volume. Then according to this theorem, see on the left hand side. So what is given there are a double integral. Double integral means surface integral. And this circle which is drawn to show that surface is a closed surface. Sometimes it is called as a loop integral. Loop integral means the surface which is a closed surface. So according to this theorem, the surface integral of the function, see this double integral, to show that is surface integral we write a sigma below, of the function that is vector f. And this circle shows that it is a closed surface. Now here in the integrand, what is required is a infinitesimal change in the area, that is d sigma. But what happens is vector f is a vector quantity. If you write d sigma, then that integrand becomes a vector. Now integrand, that means what is there inside the integral sign, is always a scalar quantity. So in order to make it scalar quantity, we write this small change in the area as a vector. So we have the area vector, and we take a dot product between this vector f and vector d sigma to make this integrand a scalar quantity. Now this is equal to the volume integral. So volume integral is a three integrals, and V shows that it is a volume integral of divergence of the function. Divergence of the function means del dot f, and beside this very small change in volume should be there. Okay, so here the integrand is a scalar quantity because del dot f is a scalar quantity. So the surface integral of the function is equal to volume integral of the divergence of the function. Because see, this theorem is used, we have to use in many derivations in electrostatics and magnetostatics. So you should be familiar with this equation. So remember that, in short, the surface integral of the function is equal to volume integral of the divergence of the function. Now especially it is required, sometime in the derivation we come across one side is a double integral, other side is a triple integral. Now suppose you convert that double integral into triple integral. So both the sides it will be triple integral, and then we will be able to say that integrands on both the sides are equal. So for that purpose, to simplify the equation, this divergence theorem is. The second theorem, which is very important to know, is curl theorem, and it was given by scientist known as Stokes, and it is called as curl theorem due to Stokes or simply curl theorem. Now suppose you have a surface. Now this surface will have a periphery, boundary. So that boundary or a periphery is a closed curve. So now in this case, you have closed curve enclosing the surface area. Just like in the previous theorem, we have surface area enclosing the volume. So here we have a curve which is closed. It encloses within that a surface area. Then according to this theorem, see on the left hand side, this is integral and lambda is written below. That means it is a line integral. And circle shows that that line is closed. It doesn't have the initial and final point. So it is a curve which is closed curve. So the line integral of the function. So this function is a vector function. Now this a small increase in the length is written as d lambda. But integrand has to be scalar quantity. So what is done is this length is written as a vector, and then we take a dot product between vector f and vector d lambda. So that makes the integrand a scalar quantity. Now that is equal to, on the right hand side, it is a surface integral. Surface integral is double integral. To show that it is a surface integral, we write a sigma. And it is surface integral of curl of the function. So that is del cross f. Now this d sigma, that a small change in the area should be there. But if we take it as scalar quantity, then this del cross f remains there as a vector quantity, and integrand become vector. Integrand cannot be vector. So what is done is, you convert this surface area into the area vector and then take a dot product of del cross f and vector d sigma, so that integrand become the scalar quantity. So this theorem tells us that a line integral of the function is equal to surface integral of the curl of the function. And this curl theorem is used again to simplify the equations in the derivations which we come across in electrostatics and magnetostatics. Many times what happens is, on left hand side there is a line integral, right hand side there is a surface integral. So what is done is, on the left hand side the line integral is current to surface integral. So now on both the sides, left hand side and right hand side, there is surface integral. So we can equate the integrands from the left hand side and the right hand side. So this way, this curl theorem is useful in the electromagnetic theory. In short, you remember divergence theorem as double integral of the function is equal to triple integral of divergence of the function, and curl theorem as line integral of the function is equal to double integral of curl of the function.